The graph below shows how the force applied to an object varies with distance. What is the work done to move the object from 10 meters to 30 meters? Before we attempt this problem, we need to understand something about this graph. Notice how the force is on the vertical axis and distance the horizontal axis. When we're talking about a graph like this, which we can refer to as force versus distance, and if we have some graph, as we do here, this line, if we were to want to find the area underneath it, okay, doesn't matter from where to where, just the area underneath it, that area is equal to the force times the distance from wherever we started to wherever we ended. And so what is force times distance equal to? Well, it's equal to work. So to find the work done from 10 meters to 30 meters, we need to find the area underneath this graph from 10 meters, which is this point here, to 30 meters, this point here. And we can do that to find this area in here. We can do that by breaking it into two smaller pieces that we know how to calculate. One can be this bottom rectangle, okay, which I'll color in with green. We can call this number 1, just to label it. And we know how to find the area of that because it's a rectangle. The other chunk, this triangular piece up here, we can call number 2, and we know how to calculate the area of a triangle as well. If we find both those areas, then we find the work of both of those areas, add them together, and that'll be the total work done. Let's look first at area 1. Now work is equal to force times distance. Well, in this case, our force is equal to the height of this rectangle, which we can see is equal to 4. The distance is the length of the rectangle, which we can see is the difference between 30 meters and 10 meters. So 30 minus 10 gives us the length. 4 times 20 gives us an area of 80 joules. Let's find the area, or the work, of triangle 2. Once again, work is equal to force times distance. We can, in fact, rewrite this as the work is equal to the area of the triangle, and an area of a triangle is 1/2 times the length of the base, which we can call distance, or we can call base. Let's write it as base, times the height, which is the force. Well, we have 1/2 times the length of the base, which we found earlier over here, is equal to 20. And the height, we can see if we look at the height of this triangle, is 8 minus 4. Right? Because we took the highest point of our triangle, which is 8, and subtracted the lowest point of the triangle, which was 4, to give us the height of the triangle. So finally, 1/2 times 20 times 4, which is 2 times 20, or 40 joules. Add these two together, so our total work is 1 plus 2. In other words, the area 1 and the area 2. I probably could have labeled that differently, but that's okay. 80 joules plus 40 joules gives us the work to be equal to 120 joules.